Welcome to Math Challenge 435. In Math Challenge 435, we are given a figure, two semicircles inside a quadrant. The entire figure is a quadrant and you got two semicircles of unequal size. Now we have to find the area of the red region. The area of the red shaded region, radius of the quadrant is 6 meters. Math challenge for all quantitative and numerical aptitude tests. Now radius of quadrant is 6 meters given. So this is the radius of the quadrant. So diameter of the lower semicircle is also 6 meters. The radius of the quadrant is also the diameter of the lower semicircle. So diameter of the lower semicircle is 6. So radius is 3. So if this is the center, this is 3 plus 3. For the semicircle, the radius will be 3 and the diameter will be 6. And the upper semicircle, which we have to find out, we have marked R. R is the radius, so the diameter will be R plus R. So radius of the lower semicircle is 3 and radius of the upper semicircle is R because the quadrant radius is 6 given. So join the centers of the semicircles. The upper semicircle and the lower semicircle, we join the centers and we get a right angle triangle. We get a right angle triangle when we join the two centers, the centers of the two semicircles. Base is 3. Base is 3. Height is, the total is 6 minus this radius r. So the height will be 6 minus r. The total vertical, that is 6, that is the radius of the quadrant, minus this r, radius of the semicircle. So the remaining part will be 6 minus r. So the base is 3 and the altitude is 6 minus r. And the hypotenuse, you can see, is the radius of the upper semicircle plus radius of the lower semicircle. The upper semicircle radius r and the lower semicircle radius 3. So the total would be r plus 3. So we have got in the right angle triangle base 3, altitude 6 minus r and hypotenuse r plus 3. And by Pythagoras rule, we can say r plus 3 whole square minus 6 minus r whole square is 3 square. R plus 3 whole square, hypotenuse square, minus 6 minus r square, that is the altitude square, is equal to base square 3 square. And when you expand and simplify, you will get r equal to 2. You have to expand using a plus b whole square formula and a minus b whole square formula, and you will get r equal to 2. So the radius of the upper semicircle is 2 meters. So now area of the quadrant, 1/4 of the area of the circle, 1/4 pi r square, that is 1/4 of pi into 6 square, that is 1/4 of 36 into pi, 9 pi. Area of lower semicircle, half into pi into radius 3, 3 square, half into pi into 3 square, that is 9 by 2, 4.5 pi. Area of upper semicircle where radius is 2, 1 by 2 into pi into 2 square, that is 2 pi. So the area of the red region would be area of the quadrant minus area of these two semicircles. So area of red region would be 9 pi minus, subtract the white area, that is the two semicircles, 9 pi minus within bracket 4.5 pi plus 2 pi. That is 9 pi minus 6.5 pi, that is 2.5 pi. So 2.5 pi is the required area of the red region. You can keep it as 2.5 pi, or you can multiply by the value of pi, 2.5 into 3.14, giving you 7.85 square meters approximately. Or you can leave the answer as 2.5 pi. we are finding out the area of the quadrant as 1/4 of the area of the circle with radius 6. Area of the lower semicircle is half of the radius of the circle, half of the area of the circle with radius 3, and upper semicircle area half of the area of circle with radius 2. We get 9 pi, 4.5 pi, 2 pi. From the quadrant area, we subtract these two areas and we get 2.5 pi, which you can keep as 2.5 pi or multiply by the value of pi to get an approximate value of 7.85 meters, square meters. That is the area of the red region.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.